Welcome to all of you to today's class. Today we'll see uniform continuous. Many of the students found difficult in this chapter, so we'll study the basic and the definition, and we'll try to understand what is uniform continuous. So first of all, see the definition. It is saying if be a real valued function that means it is the domain of this function is real numbers. Real valued function defined and a set D defined on a set D which is a subset of the real number is said to be you see on D means that set, that particular domain. If for each epsilon greater than 0, we should have a epsilon. That means epsilon here is a very small positive number. Epsilon greater than 0, there exists a delta greater than 0, such that if you will take 2 points from the domain, such that if you will take 2 points, so that let x and y belongs to the domain D. If the distance between these 2 points is very small, that means x minus y, modulus of x minus y is less than delta, such that if we will get the functional value at x minus functional value at y, modulus of this quantity should less than epsilon. If this value is less than delta and we will get the functional value of this at this point is less than epsilon, then we can say this function is uniformly continuous at the particular domain. For understanding, we will take 2 examples. So let us see some examples. So in many exams, we have seen the question, a common question is there. F of x equals to x square. F of x equal to x square. And for all x, the domain is given here, the real number. The domain is here, real number. So let us take, according to the definition of the UC, we have seen if we will take 2 points from this domain, let us see, we have let x and y are the 2 points from the domain belongs to R, and we have given from the definition, according to the definition of the UC, uniformly continuous, x minus y, distance between these points, modulus of x minus y should less than delta. Then if you will find and show the functional value at x and minus functional value at y is less than epsilon, then we can say this function is uniformly continuous. So let us see, find out the value. If you will see this is less than epsilon, then you can say this function is uniformly continuous at this domain. And let us see, we have given x minus y is less than delta. So f of x, so put this as x square and minus y square, and x square minus y square. According to the inequality concept, we can write it this like as less than or equals to x minus y, modulus of x minus y into modulus of x plus y. So from this we have seen x minus y modulus is strictly less than delta. So we can write it this strictly less than x minus y is here we can substitute delta and x plus y, modulus of x plus y. So if I will take this term as epsilon, then let us take this term as epsilon. Epsilon equals to delta multiplied by x plus y, modulus of x plus y. So here see, I can write delta equals to epsilon upon x plus y modulus. So if I will take any 2 points, from this domain R, it will give a unbounded solution. So this is not uniformly continuous. And a very important point in uniformly continuous, our function is uniformly continuous when we can write delta in the function or in terms of epsilon. It is only dependent on the epsilon, but it is not dependent on the points. It is not dependent on the points. When it is dependent on the points, it is not uniformly continuous. But when we found that is if this x plus y, modulus of x plus y is bounded, that means it will give a bounded solution, then this function is uniformly continuous. So we will see for this concept, when it is a bounded solution, this is uniformly continuous. So we will see in the next example. So this is not uniformly continuous. So let us see another example. So in previous example, we have seen that the function was not uniformly continuous on the real number. But here I will take the same question, same function, that is f of x equal to x square, but I will change the domain because I will take if interval of a finite length. So let us here domain is x belongs to 1 to 4, closed interval of 1 to 4. So let us check now. According to the definition of the uniformly continuous, so we have given x minus y is less than delta, and here functional value f of x minus f of y modulus, so which is equals to x square minus y square modulus, so which is less than or equals to, according to the definition of modulus inequality, x minus y into x plus y. So x minus y is strictly less than delta, so I can write here strictly less than delta into x plus y. So I can write it as epsilon equals to delta into x plus y, modulus of x plus y. And we can write delta equals to epsilon upon x plus y, modulus of x plus y. But here you can see our interval is a closed interval of 1 to 4, and this x plus y, modulus of x plus y, will give the maximum value at 4. So this term, if I will write, I will put x equals to 4 and y equals to 4, this term will give the maximum result. So this term will less than if I will put the x equals to 4 and y equals to 4, this term is always less than for any value. So I can write it as 8 into delta. So this term is less than 8 into delta. So here I can write epsilon equals to 8 delta. So here I can write delta equals to epsilon upon 8. So which is completely, here delta is completely dependent on epsilon. So here delta is completely dependent on epsilon. So this function is uniformly continuous on this domain.